Good afternoon, everyone. My name is Miss Karen Vigavileño, your general chemistry teacher. So for today, let us going to continue the part 2 of naming of compounds. So our objectives, number 1, differentiate binary and ternary compounds in the rules in naming acid, and practice chemical nomenclature, writing the chemical formulas of ionic compounds and molecular compounds. Okay, so at this time, let us differentiate between binary and ternary compounds. Binary compounds are compounds that contain two different elements. Okay, two different elements. So it is also named the metal first and the non-metal as IDE. So it composed of metal and non-metal. While ternary compounds, it contain three different elements, and it also named the metal first or the cation, and it is always attached to polyatomic ions. Okay, so these are the following examples of binary compounds and ternary compounds. So in binary compounds, so we have a molecular formula of water. We have two elements here. We have hydrogen and oxygen. So it is water. Another example of binary compound, we have H2O2. So it is hydrogen peroxide. Another example of binary compound, we have the NH3 or ammonia. So it composed of two elements, which is the hydrogen and the nitrogen. Then another example, we have the binary CH4 or the methane gas. So it composed of two elements, which is the carbon and hydrogen. So for ternary compounds, we have the methanol. Methanol is composed of carbon, hydrogen, and oxygen. So three elements here. Another example, we have the ethanol. So we have carbon, 2 moles of carbon, 6 moles of hydrogen, and 1 mole of oxygen. Another example, the last, we have the sucrose or sugar. The molecular formula, we have the C12, H22, and 11 oxygen. So it's also composed of 3 elements. So next, we need to know the different rules in naming binary compounds. So first, let us define what is an ionic compound. So ionic compound is made up of cation. Cations are metals with a positive charge, and anions are metal with negative charges. They are named by giving the name of the cation first, so the metal first, followed by the name of the anion. So always take note that in metal first, cation, its name does not change, followed by the name of the anion, or it depends by its suffixes. So example, we have sodium iodide. So the first element is metal, so its name doesn't change. While in the second name, so it is non-metal, so it's changed into IDE. So it is an ion. Another example, we have magnesium. So magnesium is a metal, while chloride is a non-metal, so it is cation. So it is changed into IDE. So at the end of the name, so it's suffix IDE. Another example, we have the iron. Iron is a metal, while sulfur is a non-metal, so it becomes sulfide. The next, we have potassium. So potassium does not change its name because it is metal. And the second name is oxygen, which is changed into oxide. So it is non-metal. So before we proceed to our next type of bonding, let us compare first the difference between covalent bond and ionic bonding. So we have the species involved. So in species involved, of course, we have the atoms. And it is the transferring or sharing of electrons. So in covalent bond, it is the sharing of electron. Okay, so our electrons are shared. So in their interaction, they balance of attractive and repulsive forces between atoms. So there is a positive and negative charges. So positive and negative attracts, while both the same charges repel. Okay, so covalent bond can be polar or non-polar depending on its electronegativity. For example, here we have H2O. So always remember that covalent bond are those bonds composed of two nonmetals. Okay, two nonmetals. For example, we have H2O, so hydrogen and oxygen, and chlorine gas. So Cl2, so 2Cl is both nonmetals, or they are both nonmetals. Next is the characteristic of ionic bonding. So in ionic bonding, it composed of both metal and non-metal. Take note, it is composed of a compound that they have metal and non-metal. So what are the species involved? So it is the cation and an ion. So positive charge and negative charge. So their electrons can be transferred. So it is taken by more electronegative participants. So they have a weak electrostatic forces. Then the examples are NCAl, so sodium chloride. We have the cation sodium and the anion, the chlorine or the chloride. Then another example, we have calcium carbonate. So calcium is a cation and carbonate is an anion, an example of polyatomic ion. So another example, we have the way how electrons are transferred or shared. Okay, so we have ionic bond. So ionic is composed of metals and nonmetals. So the valence electron here is 1 transferred to Cl. So when electron is transferred, the metal will be positive. Then while the chlorine accepts its electron, it becomes negative. So positively charged sodium and negatively charged attract to each other and electronically bonded together. So they bond together. So they attract because they have positive and negative charge. In covalent bond, as you can see, there is a sharing of electrons. Okay, electron cannot move independently, and the atoms form bonds by sharing of electron. Again, ionic bond is a transferring of electron, while covalent bond is the sharing of electrons. Okay, so these are the periodic table. This is the periodic table of your elements. So we have alkali metals. So we have the legend here. Alkali, the earth metals. We have the transition metals, the basic metal, semi-metal. We have the halogens, the noble gases, the lanthanides, and the actinides. So this part or the non-metals. Okay, so next is the molecular compounds. Molecular compounds are also known as covalent compounds. So covalent compounds is composed of both nonmetals. So it is made up of two nonmetals. So they are named by giving the name of the first nonmetal, and then that the second nonmetal is modified by ending IDE. Okay. So, in these molecular compounds, we are uses the prefixes for naming covalent compounds. So, these are the prefixes added to each element in the name. Okay, for example, we have mono, so it composed there is one element. Two, we have two elements. Tri, we have three. Tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. Okay, so in molecular compound, always remember that it is only used, we will use these prefixes for covalent compounds only, not in ionic compound. Okay, so for examples, we have the number of atoms, the prefix that we use, and the examples. So, for molecular compound, number 1, we have an example. We have nitrogen monoxide. Why? Because nitrogen monoxide, it composed only of one nitrogen and one oxygen. Dinitrogen dioxide or nitrogen dioxide. So, nitrogen 1 and dioxide 2. So, 2 moles of oxygen. Next, we have the dinitrogen trioxide. Why? The nitrogen trioxide composed of 2 nitrogen and 3 moles of oxygen. So, trioxide. Next, we have dinitrogen tetroxide. So, as you can see in the formula, we have 2 nitrogen and 4 oxygen. Next, we have dinitrogen pentaoxide. Why? So, this molecular formula has 2 nitrogen and 5 oxygen. So, it is penta. Next, we have sulfur hexafluoride. So, 1 sulfur and 6 fluoride. So, hexafluoride. Next, we have iodine heptafluoride. So, 1 iodine and 7 fluorine. Number 8, we have tetra. It is tetraphosphorus. 4 phosphorus and 8 oxygen. We have tetraphosphorus decoxide. 9, we have the tetraphosphorus nonasulfide. 4 phosphorus and 9 sulfur. Then last, we have 4 arsenic and 10 oxygen. So, it is tetra arsenic decoxide. So, these are another examples. We have the hydrogen chloride, the carbon dioxide, the sulfur trioxide. So, each Cl composed of 1 hydrogen and chlorine. Carbon dioxide, 1 carbon, 2 oxygen. Sulfur 1 and 3 oxygen. The next are the rules in naming ternary compounds. So these compounds are composed of metals and polyatomic ions. So the naming of ternary compounds follows the same rule as that of the binary ionic compound. The name of the cation is given first, so it is the metal, followed by the name of the anion. So it depends. But it is usually used in polyatomic ions. So for examples, we have sodium nitrate. Sodium is a metal and nitrate is a polyatomic ion. So barium chromate, we have barium is a metal and chromate is a polyatomic ion. Next, we have the potassium sulfate. Potassium is a metal and sulfate is a polyatomic ion. Next are the rules in naming acids. Okay, so letter A or number 1, we have the binary acids. So it composed of hydrogen and another element. It is usually a non-metal. Okay, so the first part of the name starts with the prefix hydro, followed by the name of the element modified by the ending IC. The second part consists of the word acid. Take note. So the name first, which is the hydro, the root name of the element IC plus the acid. Examples, we have hydro chloric acid. We have the hydroname first, the IC or the for the word chloric, and acid. Next, hydrosulfuric acid, and we have the hydroic acid. Okay, so for ternary acid, so this ternary are composed of three elements. Okay, made up of hydrogen also and the anion usually containing hydrogen. The first part of the name consists of the root word of the name of the element modified by ending IC. The second part consists of the word acid. If there is another acid with the same atoms, the suffix OUS is used to denote the one with less number of atoms. So we have the name, the root name of the element, we have the IC or OUS plus the acid. So by naming IC or OUS, it depends by the number of the charges and the element. So examples, we have the nitric acid, then we have the nitrous acid, then we have the sulfuric acid, and the sulphosphorus acid. Okay, so those are the different rules in naming binary compounds and acid. Okay, so I hope you learned this lesson for today. If there are any question, don't hesitate to ask me. Okay, so thank you for watching and listening.